Hello, everyone. So, today's topic is about hypothesis testing. Now, as you all know, this concept underlying this is quite familiar, and there are a variety of non-statistical application of hypothesis testing. The best known of which is the criminal trial. Okay, so when a person is accused of a crime, he or she faces a trial. The prosecution presents its case, and a jury must make a decision on the basis of the evidence presented. In fact, the jury conducted or conducts a test of hypothesis. So there are actually two hypotheses that are tested. So the first are called the null hypothesis and is represented by HO or pronounced as H naught in a British term for 0. So it is the H naught is the defendant is innocent. So the null hypothesis is the defendant is innocent. And the second is called the alternative or research hypothesis and is denoted with H1. In a criminal trial, that is, the defendant is guilty. Of course, the jury does not know which hypothesis is correct, so they must make a decision on the basis of the evidence presented by both the prosecution and defense. So there are two only possible decisions: convict or acquit the defendant. In statistical parlance, convicting the defendant is equivalent to rejecting the null hypothesis in favor of the alternative. And that is, the jury is saying that was enough evidence to conclude that defendant was guilty. So acquitting a defendant is phrased as not rejecting the null hypothesis in favor of the alternative, which means that the jury decided that there was not enough evidence to conclude that defendant was guilty. So notice that we do not say that we accept the null hypothesis. In a criminal trial, that would be interpreted as finding the defendant innocent. Our justice system does not allow this decision. So there are two possible errors: a type 1 error occurs when we reject a true null hypothesis, and a type 2 error is defined as not rejecting a false null hypothesis. So in a criminal trial, a type 1 error is made when an innocent person is wrongly convicted. A type 2 error occurs when a guilty defendant is acquitted, and the probability of a type 1 error is denoted by alpha, which is called the significance level. So the probability of a type 2 error is denoted by beta, a Greek letter beta, and the error probabilities alpha and beta are inversely related, meaning that any attempt to reduce one will increase the other. Okay, so we have here a table 1, terminology of hypothesis testing. So if the null hypothesis is true, which is the defendant is innocent, and we convict the defendant, it means that we reject the null hypothesis. Thus, we will have a type 1 error. So if we convict the defendant and reject the null hypothesis, but the defendant is guilty, so yes, we have a correct decision. And when we reject the null hypothesis, we do not reject the hypothesis, it means that we acquit the defendant and the defendant is innocent. Therefore, we have a correct decision. But if we do not reject the hypothesis and the defendant is guilty and we acquit the defendant, thus we will have a type 2 error. So critical concepts in hypothesis testing follow. There are two hypotheses. One is called the null hypothesis and the other the alternative or research hypothesis. And the testing procedure begins with the assumption that the null hypothesis is true, and the goal of the process is to determine whether there is enough evidence to infer that the alternative hypothesis is true, and there are two possible decisions. Conclude that there is enough evidence to support the alternative hypothesis and conclude that there is not enough evidence to support the alternative hypothesis. So two possible errors that can be made in any test, and we have a type 1 error, occurs when we reject a true null hypothesis, and type 2 error occurs when we do not reject a full null hypothesis. So the probabilities of type 1 and type 2 errors are probability of type 1 error is equals to alpha, and the probability of type 2 error is equals to beta. Thank you for listening. See you on the next video.